everyone, welcome back to my video blog where I talk about Azure, data services, and some personal development. I want to say a quick thank you to all of you new subscribers and those who are liking and commenting on these videos. It's certainly very motivating. So today we're going to pick up with part 4 of the modern data warehouse in Azure and talk about how to set up our data for presentation in our serving layer, okay? Just to recap, in parts 1, 2, and 3 of this series, I talked about data ingestion, data storage, and data processing. So now that we've done all that data aggregation and curation, deeming the data worthy for presentation, we have this final step. Now, one could argue that this is the most important step of the process to this point in building our data warehouse, because it really requires that all of our data has been cleansed and is ready to be shaped for optimization and performance before we load it into our reporting tools, or the presentation layer as it's commonly known. If we continue to look at the Kimball methodology for deploying our data warehouse, we're going to build our Snowflake or star schema in this phase. Depending on requirements, we can either load it into memory, like Azure Analysis Services, or use something like SQL Database or Azure Synapse just for forming the schema and ultimately loading our presentation tool. Now, I'll use Power BI as the example for talking points here, but no, because of the nature of these services, there is a lot of flexibility. So if you're using a different presentation tool, you can either load the data into its semantic layer with some orchestration, or connect to newly released XMLA endpoint in Power BI or Azure Analysis Services. Now, much like the other topics in this process, there's quite a bit of flexibility in this step to decide on which tools you'd prefer to use. We'll start to see it will really largely depend on our specific use cases for how much data we're shaping and how quickly that data needs to be processed. In this stage, you're going to still have to evaluate how you want to load large fact tables as you would with a data warehouse on-prem. And there are quite a few patterns that have been shared for concepts like slowly changing dimensions and some of the more difficult data warehousing decisions and strategies, really, because they're almost asking you to predict the future in the way and know how the business will require the data over time as it evolves. Now, I've mentioned before, we always need to evaluate cost against performance and features. So it's a much easier decision if cost is no object, right? But out here in the real world, that's rarely the case, right? And so let's jump in and talk about the tools we may use for the serving layer with some examples as to why you might use one over another. So leading off, we'll start with one of the most exciting new Azure services, and that's called Azure Synapse. At its core, Azure Synapse is Azure SQL Data Warehouse rebranded, and as time goes on, we'll have lots of great new features added to it to allow for big data and data warehouses to be developed in all the same graphical user interface. The Azure SQL Data Warehouse has some really deep roots within Microsoft as a massively parallel processing engine for online analytical processing, so MPP and OLAP or OLAP. Really processing these massive amounts of data in parallel across numerous compute nodes, right? Prior to becoming an Azure service, it was an on-prem appliance called an APS, and then prior to that, the PDW. Now, the architecture of the SQL MPP engine in Azure Synapse allows for a separation of compute and storage, right? So that when the storage is not in use, when the compute is not in use, then we turn the compute off and we're only paying for the storage, which is relatively inexpensive. That'll help us save significant costs, right? But the data will still persist, and we can access it when we need to process it using that compute and turning it on demand with some sort of tool, whether it be through a PowerShell script or through a query. You can do it through the GUI. There's a lot of ways to do that. Now, depending on whether you're loading a fact table or a dimension table and the sizes of those tables, There are configuration considerations for indexes and the types of tables you're going to load in Synapse for maximum performance. I'm not going to go too deep into some of those tables and round robin and heaps and stuff like that, but a quick search on optimization in Azure Synapse or maybe SQL Data Warehouse for the previously named product, you're going to find a ton of results, right, out there on the web, and they'll give you some great strategies. Now, some other traditional data warehousing strategies come in, like whether to truncate and reload or only update and insert some of your newly changed records and things like that. So be prepared to make some of those decisions along that way. But the real power of Azure Synapse is to be able to bring those massive amounts of data and process it in a shorter amount of time. On the other hand, for some of your smaller workloads or less restrictive data refreshes, when it comes to your SLAs, it might make sense to look at the Azure SQL database as your serving layer from a pure cost perspective. So we'll look at this as our second option, right? I'm going under the assumption here that you don't need the performance of an MPP engine because you're just laying the schema out for consumption from a different semantic layer. In this case, like pulling the data into Power BI dataset, using a refresh schedule, and not doing something like direct query with Power BI, as this could cause performance issues depending on how much data or how many connections you're making to that data in direct query. Azure SQL Database is a very robust option for housing this data with many features for considerations like data governance, data discovery, and security. Oftentimes, I make this recommendation to customers as a first option for any data that is expected to be less than a terabyte, also knowing many terabytes can be handled, but when we get to data sizes that large, we can't keep up with the SLA demand for the refreshes. So definitely make sure this is one of the services you consider to maximize cost savings and capability. Now, a third option is to look at really what are two options, and that's going to be Azure Analysis Services and or Power BI. Now, I did a video a while ago about whether I would choose Azure Analysis Services or Power BI and some of the reasons I would still pick Azure Analysis Services. Both of these are in-memory options, and essentially you're creating your schema in memory in those tools. Now, the reasons that I would choose AAS real quick are if you have granular security requirements, and AAS allows for object level security, whereas Power BI, for the time being, only allows for row level security. Also, Azure Analysis Services can be scaled up or down to increase or decrease compute, as well as in or out to add nodes as you need to process more data. Now, this can be done automatically, but it can't be done with Power BI as you're tied to a tier of compute, and it's not possible to scale up and down due to demand or turning the compute off when not required, for the time being at least. This is definitely something that they're working on in the background. Now, behind the scenes, they're both using the same engine, which is the Vertipack in-memory processing engine that allows for very snappy, interactive reports with the data and the visuals, as well as achieving pretty significant columnar compression rates for certain data types, like say ints and things like that can be compressed really well. The drawback of using this in-memory engine is that there are limited resources, and the more data you're loading, the more memory that is being consumed, and for larger data sets requirements, you will start to begin to take a performance hit. One approach would be set up separate data marts for functional areas of the business and build reporting off of those data marts, okay? Now, there are some other options here for serving up the data for open source, like Databricks or HD Insight, as well as third-party vendors like Snowflake. So be aware of those options as you start to evaluate. Oftentimes, those decisions will come down to certain feature requirements and comfort with open source solutions or not. But be sure to evaluate your price, your performance, and the features as part of the overall solution. Where one product may have a feature, another may not, don't fall for the marketing. And be sure to evaluate the features you really need and understand the roadmap for missing features before you make your final decision, right? It's always nice to have those best case scenarios, but if it's going to cause other challenges with, say, the development team or connectivity or capability of connecting to other sources or presenting that data to other tools, make sure you consider all that stuff. Okay, so now you've staged the data and you're really ready to start building some reports, okay? Hopefully this will give you a reference for what you need, no matter which presentation tool you're going to use, as it should be fairly agnostic as to which tool you need, because you can connect to these tools from a whole bunch of different reporting applications. I hope this overview has been helpful. If it is, please help me out by liking, sharing, and subscribing, as everyone motivates me just a little bit more to make my next video. Thanks for watching, and have a great day. Bye.